Give the negation, converse, and contrapositive of the statement all A's or B's are C's. It is much easier for me to negate a symbolic statement, and so what I really want to do is negate the statement that says all X, so all X, that is either A or B, is a C. And to negate an all, we need to make it existential. That means something exists that violates that requirement. So to negate that, I'm going to say there exists an X such that it does something. Let me think about that for a moment. What I want is that there exists an X that violates all A's or B's or C's. So we're going to look at an X that's an element of the set A, or an X that's an element of the set B, and we want to negate that that's an X that's an element of the set C. Now we actually did that, but it says give the negation, not the symbolic statement, so we need to write this out. We would write this as there is or there exists, so there exists an A or B which is not a C. Okay. The next part is to find the converse, and what the converse does is it switches the hypothesis and the conclusion. So a converse of P implies Q is Q implies P. Again, it's much more straightforward for me to do this symbolically, so I'm going to say all X, okay? And that is an X that's an element of C is either X an element of A or X that belongs to B. So symbolically that's correct, but we need to write this in an English sentence. So we would write that all C's are either A's or B's. Keep in mind that this is a converse of a statement is not necessarily equivalent. There might be instances in which it is, but it is not an equivalent to the statement. Give the contrapositive of the statement. The contrapositive, so the contrapositive of P implies Q is not Q implies not P. And the contrapositive of a statement is equivalent to the original statement. So let's mess with that for a minute, okay? So for every X that's not in C implies that the X is not in A or X is not in B. This is a cumbersome way to say stuff, so let's use De Morgan's laws. And using De Morgan's laws, we would say that for all X, okay, an X that's an element of C or an X that's not an element of C implies that X is not an element of A, and at exactly the same time, X is not an element of B. Again, we need to convert this to an English statement, so I would write this as all non-C's are non-A's and non-B's.